Ms. Tucker, I had a quick question for you.
Yep.
I received notice that, because I'm going to school using my GI Bill. I received notice that the exemptions that the veterans using GI Bill that allows us to do virtual classes is going to end December 22nd. Do you know, is TCC going to start offering more in-person classes?
So now hold on. You said what isn't in December 22nd?
So for the veterans, there was an exemption put into place to where we can do virtual classes without it affecting our housing allowance that we're given every month. But if we decide to do virtual classes beyond December 22nd, which is when the exemption ends, then our housing allowance is going to be cut in half.
Oh, got you. Yeah, so yeah, next semester we are going back. I just was trying to get the correlation between the two. Yeah, so yeah. They're going back at least at 50% capacity. That's the goal.
Okay.
Yeah. So it should have way more opportunities to have
Ron, you should be able to reach out for an extension. Like, because you have kids, so with COVID, you should be able to reach out for an extension for that reason only. So I would reach out to your benefit holder for your GI Bill and just say, hey, look, I know this is only a temporary extension, but COVID's still rampant. I still got kids I got to deal with. Is there any way I can get an extension? They might be willing to work with you.
Yeah, I'm definitely going to hit up the VA office at the campus and see what's up.
And if the one at the campus doesn't help you, then hit up the VA directly and they should be able to help you.
All right, cool. Yeah, because I was freaking out last night. I was like, oh my God, how am I going to do that?
Yep. All right. So good morning, everyone. Hope all is well. Hope everybody's doing all right. Got a great section for you today. When I was going over it in my last class, all I could think about was this class and how much you guys are going to love it. So let's go ahead and get in there. Let's see where my page and notes. All right, so let's scroll on up. 3.4, zeros of polynomial functions. So remember, we talked about last class that zeros, roots, solutions are the same thing. So, it says zeros of polynomial functions, or it could say solutions of polynomial functions. We'll come back to it if we have time. So we're going to finish out chapter 3 first when it comes to 3.2. All right. So the first thing we're going to come across in this section is the rational zero theorem. So keyword here is rational. We're just talking about the rational zero theorem. So that's the list of all possible rational zeros. And you'll see what I mean when we, as we go down. That part. So to find the list of all possible rational zeros, we're going to take, and plus or minus is going to be attached to each one of our numbers created. But we're going to do plus or minus the factors of your constant over the factors of the leading coefficient. So everybody done with the title? All right. So to find the list of all possible rational zeros, so in other words, let's say if you come to an equation, which is what we're going to do in a few, we're going to come to an equation. We have no clue as to where to start. We have no zeros, no hints. At least this is a way we can have a list of possible solutions. And so that's what this gives us, a list of possible rational solutions. And so where this comes from is that, let's say if we had the equation 2x plus 3 equal to 0 and we want to solve. If I were to solve for that, I would subtract 3 from both sides, divide by 2. Notice my constant. The constant is the number that is not attached to your variable at all. Notice that ends up being on top. And then my leading coefficient is the number that's sitting in front of my variable with the highest exponent. that ends up being on bottom. So that's where this thought process come from, is that your factors of your constant is over the factors of your leading coefficient. All right, any questions on that before we try it out? We see down there in the green, list all possible rational zeros of f of x equal to 15x cubed plus 14x squared minus 3x minus 2. Can I scroll up? All right. So the first thing you want to do is establish what is your constant, what is your leading coefficient. So your constant is always the number that's not attached to your variable at all. And then your leading coefficient is always the number attached to the variable with the highest exponent. So our highest exponent is 3. And so that's our leading coefficient, 15. 15 will be our leading coefficient, not the 3, but 15 will be our leading coefficient. Okay, so is everybody okay with this part? Establishing what's your constant, what's your leading coefficient? All right, so now to get our list, we're going to take each one of our factors from 2 and place it over each one of the factors from 15. Nope, we're not worried about a sign. No. The sign is going to be talked about in a second. But so we take each one of our values from 2, place it over each one of our values for 15. So
the 1 times 15 and the 3 times 15, is that an either or do you need both of those?
Yep, you need all of them.
Okay.
Those are all your factors of 15. So 1 times 15 and 3 times 5. Those are the different ways you can get 15.
So you need all the factors of 15.
Okay. Yep. And the only reason we only had 2 for 2 because the only thing we got is 1 times 2. Yep. So notice what we did here: 1 over 1, 1 over 15, 1 over 3, 1 over 5. Then 2 over 1, 2 over 15, 2 over 3, and 2 over 5. So that gives us our list. And this plus or minus goes to each one of the numbers. So when somebody asks, do we keep the sign here? That's why it doesn't matter, because we're using plus or minus here for each one of the numbers. So I just shorthanded it and just put it in front of the first one, but the plus or minus goes to each one. And then simplify the list if possible. So 1 over 1 is just 1. Then you have 1 over 15, 1 over 3, 1 over 5. 2 over 1 is just 2. 2 over 15, 2 over 3, and 2 over 5.
So you shorthanded your answer again. They would all have plus and minuses in front of them as well.
Mm-hmm.
And
So,
can you write it in Math Lab that way? Just 1 plus or minus, and then
they're going to give you a list to choose from. In other words, A, B, C, D, or E. And like, let's say one of the lists won't have 1 over 5 in it or something like that.
Okay.
So if you put plus or minus in front of each one of those, there should be 16 possible rational solutions.
Did you put the 2 over those numbers because of the constant?
Mm-hmm.
Okay.
All right. Is that okay to try it again? All right, so let's do it again just to make sure we're okay with the process. We have 4x to the 5th minus 12x to the 4th minus 6, oh, minus x minus 6. All right, so our constant is 6 and our coefficient, leading coefficient is 4.
But is it 6 or is it -6?
No, it doesn't matter. Because we're gonna do plus or minus as far as our list is concerned. So it's not gonna matter. All we need are the factors of 6, which is 1, 6, 2, 3. Factors of 4, 1, 4, 2, 2. All right, so we're going to place the factors of 6 over the factors of 4. Now notice we have 2 times 2 here, so we don't have to repeat it. So really all we're doing is 1, 4, and 2. Sir, is there anything I can do to help you out there? You said your brain not processing. All we're doing is creating a list of possible solutions.
Can you go back up to the rules of this momentarily?
Yeah, let me give people a chance to finish copying. Is there a particular reason why you have stepped into a vortex, sir?
Because like I'm just like thinking.
Huh?
Okay, why do you want the constant? Why do you want the coefficient?
Oh,
It's like
no.
none of this is me.
Time out. You're echoing. There's an echo chamber. I was talking about the vortex that you stepped into, not your not your situation, not what you're trying to figure out. No, it's like you're echoing. That's why I was asking you about the vortex you stepped into. But
Yo, he went into the matrix for real.
right. All right. So is everybody done copying this before I scroll up to make sure he has understanding? Then we'll finish our list. Just want to make sure. Didn't want to cut someone off from what they were, processing. All right. So what we did so far up to this point, we put 1 over 1, 1 over 4, 1 over 2. And like I said, we didn't need to repeat, 2 because, it's the same number. So and then we did 6 over 1, 6 over 4, 6 over 2, 2 over 1, 2 over 4, 2 over 2. All right. And while we're here, let's just go ahead and finish the list.
Can you, before you scroll down, can you explain why you didn't use that last 2 again?
It would be the same number.
It'll just be redundant.
Yeah.
Okay.
Now, if that was 3, then you would have to do it, because that would create a different number. So let's go ahead and finish the list, and then we'll scroll back up for Mr. Bracy. So now you go ahead and simplify as much as possible, and then if anything's repeated, just like your classmate mentioned about redundancy, you don't want that. 1 over 3. Well, 1 over 3 wouldn't be 1 because actually we're doing 3 over 1. You take your constant and put them over the leading coefficient. I think that's what you're asking. So you would do 3 over 1, which is what we did here, not 1 over 3. All right. Okay, gotcha. So 1 over 1 is just 1. 1 over 4 is 1/4. 1 over 2 is 1/2. Then we have 6 over 1, which is 6. Now 6 over 4 reduces to 3 over 2. 6 over 2 is 3. 2 over 1 is 2. 2 over 4 is 1/2. So we don't have to repeat that. 2 over 2 is 1. Don't have to repeat that. 3 over 1, we already have that. 3 over 4, we don't have that, so we use it. And then 3 over 2 is already repeated. Yes, sir. Factors over the constant tops. The factors of the
Okay. Does this sound better?
Yeah.
All right. Then you simplify them, and if you get any repeaters, you just.
Yep. Welcome back, sir. Any questions on the process? So you put your constants over the leading coefficient, and that will give you your possible solutions. Mr. Bracy over here ducking bullets. Any questions? Any questions?
And it's 16 possible zeros because it can be negative and positive.
Exactly.
Why does it say 16 possible zeros, but there's only 8 numbers? Oh, I get it. Never mind. Stupid question.
Are you fine? But yeah, so just for anybody else that didn't catch it, plus or minus goes to each one of these. So like she said, you see 8, but that's plus and minus 1, plus and minus 1/4, plus and minus 1/2, and so on. All right. Let's go to the next one. So now they're asking us to find all of the zeros of a solution, and they didn't give us any hints. So what we would do is create our list of possible solutions, and then either do synthetic division, or we can plug them into the equation. Remember, we talked about last class that we can do synthetic division and get 0, or do the remainder theorem and get 0. As long as I get 0, either one of those will give me, let me know that I have a solution. So once again, we establish what is our constant and what is our leading coefficient. So our constant is 3, and our leading coefficient is 1. That's what's sitting in front of x cubed. Also, the x cubed lets us know we should get 3 solutions here.
Is that 350 in the green above the 3?
So in the green above, oh, right here?
Yeah.
Man, that's SOL. That's 3 solutions, man.
Oh, bro. We got to work on your calligraphy for real.
Oh, man, I gave that up a long time ago.
That makes more sense. I'm like, what in the 3 solutions make sense? All right.
350? Anybody have any questions before we go to the next step? So
Wait, I missed the whole thing. Okay, is that a purple 1, or did you?
that's a
X out?
purple 1. I was just saying that's what's sitting in front of x. That's my leading coefficient.
Okay.
Yep. So I was just saying ain't nothing but a 1 in front of that. So our constant factors 1 times 3. Leading coefficient is just 1 times 1. Yep. You got it. So
It says 3 solutions though.
no. Remember, these are your possible. They
Oh,
don't give us our list of solutions. They give us our possible solutions. So now we have to establish which 1 or 3 or whatever are actually solutions.
gotcha.
It just gives us a place to start versus just coming into this thing like just starting at 0 and start plugging in random values. It tells us what our possible solutions are. And don't forget, these are possible rational solutions. So it is possible for you to have values or solutions that are imaginary or irrational that's not a part of this list. So you'll see as we progress through this. So like your classmate mentioned in the chat, 1/1, 1/3, and it's plus or minus for both. So we have 4 possible solutions here, plus or minus 1, plus or minus -1, plus or minus 3. I said, hold on, why I say it like that? Plus +1, -1, +3, -3. That's what I meant to say. 4 possible solutions. So now I'm going to do it using synthetic division just to give us more practice on synthetic division. But remember, I told you there are 2 ways you can do it. You can use synthetic division, or you can plug it into your function. Or let me make it smaller and get 0. So we're looking for 0 no matter what we do. But we have 1, -1, 3, and -3. Once again, I'm going to do synthetic division just to give us more practice at looking at synthetic division process. But I'm believing at this point, you guys are pros at plugging values into your equation. You would just take your calculator, plug -1 in there, see if you get out 0, plug in +1, see if you get out 0, plug in 3, and then plug in -1, see if you get 0 as a result. So, first one, remember our coefficients come from here. So that's why we have 1, 7, 11, and -3 right here. And then the first one I'm trying is 1. So that's why we have 1 in the box. First move is to bring down your first coefficient, and that's 1. 1 times 1 is 1. 7 plus 1 is going to be 8. 1 times 8 is 8. Oh, I did it again. Try one more time. Then 11 plus 8 is 19. 1 times 19 is 19. And then -3 plus 19 is 16. So you need 0 to be there in order for it to be a solution. Since that's not the case, it is not a solution. If you were to plug it into the function, you would have gotten 16 out as well.
So you just need that last number to be a 0 for it to be a solution?
Yes, sir.
Okay.
-1, do the same thing. We're using the same coefficients because it's the same problem that we're trying to test. So drop down 1, and -1 times 1 is -1. Add them together, we get 6. -1 times 6 is -6. Add them together, we get 5. Add these two together, you get 5. 11 and -6. And then -1 times 5 is -5. Add these together, you get -8. Once again, not a solution. All right, can I scroll up? Once again, just reemphasizing the thought process that I did all of these through synthetic division just to walk you guys through synthetic division again to get the practice in. But you could have easily just plugged these values into the function and got these numbers. So just reminding you of that. So we do the same thing for 3 and then -3. So, this type of situation is what you could be placed in if you were doing research or something like that. You could have 20 possible rational solutions. And then let's say if you ran through 19 of them and you got down, notice here, our last one we tried was actually the solution. And that's not that big of a deal if all you have is 4. But like I said, if you have 20 possible solutions and you get down to 20, that's a lot of work. But that's the type of work that you do when you actually, you're doing research and, you're trying to find this stuff because you have some thought process behind what you're trying to do, applications and all the good stuff. So, that's why people get paid the big bucks. So we only had 4 solutions, so it wasn't that big a deal for us that our last solution was an actual solution, but we see how -3 came down to 0. Now, if you would have plugged -3 into your function and he got 0, then you would have still had to divide it or do synthetic division in order to break down your function. And you'll see what I mean in a second, but you will have to break your function down to go to the next step. So at some point you have to use synthetic division or long division, but you wouldn't have to do it 4 times. You would just have to do it for the one that you find out to be a solution. So we use that -3 that we found to be a solution, like I said, to do synthetic division, and that breaks down the equation to the next level. It was at x cubed, but now we break it down to x squared. So now we have x squared plus 4x minus 1. And we cannot factor that. So best move now is to use the quadratic formula to solve. Now, if you just wanted to use the complete and squared, you could do that as well, but most people go ahead and roll with the quadratic formula. All right, so that's x equal to -b plus or minus square root of b squared minus 4ac over 2a. So a is always in front of x squared, that's going to be 1. B is in front of x, which is 4. C is the constant, which is -1. We plug those in accordingly. -4 plus or minus square root of 4 squared minus 4 times 1 times -1 over 2 times 1. Simplify as much as possible under the radical. 4 squared is 16. Minus 4 times that -1 will give you +4. Square root of 16 plus 4, square root of 20. That can reduce down to, you will break it up into 4 times 5, take the square root of 4, which is 2. Leave the 5 under the radical. Now you have -4 plus or minus 2 square root of 5 over 2. And that 2 can go into each term in your numerator. That'll be -2 plus or minus square root of 5. And that will be your other 2 solutions. Remember, we're supposed to get 3. So in the purple box, you see our 3 solutions: -3, -2 plus square root of 5, and then -2 minus square root of 5. So notice those last 2 that we just found were not rational. That's why they weren't a part of the list. Those are considered irrational when it doesn't, simplify all the way down to give you a solid number or a solid fraction. They're considered irrational, so they wouldn't be a part of the list, but they could be a solution. All right, can we scroll up?
In MATLAB, is that going to be a multiple choice question, or
that one you probably will list and
So-
separate each one of them by commas.
will it accept x minus 3 and then, I'm sorry, x equals -3, and then will it accept x equals -2 plus or minus the square root of 5?
Well, they only can do plus or minus if they give it as an option. So that would be based on the symbol selection. I forgot whether MATLAB made it available. I know at one time it wasn't there.
Oh, it's been available because I've had
Okay.
to use it for an answer in the past.
Okay.
I mean, does that mean it's going to be available then? And if so, is that still an acceptable answer? Because
Yes.
sometimes MATLAB wants you to put exactly what it
Mhm.
wants. So if it wants those 3 solutions,
Right.
it wants those 3 solutions.
Yeah, this should be fine. If they give you that symbol, then this should be okay. I know at one time it wasn't even an option. So that's why, and these notes probably leaning on that because it's fairly new. I think maybe last year or maybe the year before last when they actually, I've been teaching this for a minute. So I just always just do it just in case. You know what I
Alright.
mean? So, all right.
Up at the top, it says cannot factor use. I couldn't understand what it said, but you removed
Quadratic formula.
Okay.
Mhm.
And why exactly can we not factor it?
Well, maybe you can factor it because you just came out of the matrix, but regular people would not be able to would not be able to factor that, sir. You know, when you talk about factoring, it will come out to this. You know, you have x, so now you're looking at what two numbers that multiply to give you 1, but will subtract from each other to give you 4. And you know, the only factors
Well,
are
we use
1.
a 0.5 along with a 2, maybe.
See, there you go. All right. So anybody have any other questions before we go to the next thing?
That 4 times 5 and 2 and 5, where'd that come from?
You breaking down that 20, you know, because 20 is 4 times 5. And so now you want to take the square root of 4. That gives you the ability to take the square root of 4, which is 2. And so that's the simplest way of expressing the square root of 20, 2 square root of 5.
Okay.
Where does the -3 come from for the solution?
Remember, that was the first one we found when we did a synthetic division. And so, yep. So I'm glad you said that. Don't forget that one, because that was a part of your solution finding. Yep. Sometimes people do that, so be careful with it. I see you, Mr. Bracy. So next thing, complex conjugate theorem. If a plus bi is a solution for your function, then that means a minus bi is also a solution. So they come together, come hand in hand. So they expect, you know, from this point forward, that if you have an imaginary solution, it doesn't come alone. There's always 2. So your complex conjugate means that on the imaginary part will have a different sign. So if you have 4 plus 5i, 4 minus 5i will be the complex conjugate. If you have -2 plus 7i, then -2 minus 7i will be the conjugate. And then if you just had -8i, positive 8i would be the conjugate. It's all about changing the sign of your imaginary part. The real part stays the same. All you do is change the sign of your imaginary. All right. So this is where it gets a little fun. So we want to find a 4th degree polynomial function with real coefficients that has -2, 2, and I. Let me erase this. -2, 2, and I as zeros, such that when you plug in 3, you get out -150. So what are we doing here? And I think I have a sentence that says it. Yep. Is everybody done with that first? The complex conjugate? Scroll up to the green. Okay. So what we have here is that we're pretty much reverse engineering the process. You know, before you have a function and they will ask you to find solutions to the function. This time you have solutions and they're asking you what function give you these solutions. So we have this function that's out there that have certain conditions. First of all, it's a fourth degree. That means 4 solutions. That means x to the fourth would be the exponent on the highest exponent on our variable. They give us 3 solutions. And then they say, when I plug 3 into that function, I'm supposed to get out negative 150. All right. You said wait. All right. So let's look at our possible solutions. So in the red box, see what we did there. Yeah, that's f of 3. That means that you plug in 3 into the function and we get out negative 150, but we don't know what the function is yet. So notice they give us -2, 2, and 1. Excuse me, not 1i. But remember, the complex conjugate theorem says that if I is a solution, that means negative I has to be a solution as well. You just change the sign of your imaginary part. So before I go to the next piece, everybody okay with how we have our 4 solutions? We have -2, 2, I. They gave us that. Negative I is our 4th solution. Now, remember, we need to reverse the process. We're trying to figure out what function gives us these 4 solutions. So remember, in order for x to be equal to -2, it had to be x plus 2. You know, now for me to solve that, I'll subtract 2 from both sides and I get my -2 back. So the way we will put that back into function form is that we will do x minus whatever the solution is. So that's what we did right here, x minus -2. And we're going to do that for each one of our solutions. That's what we have in this step right here, x minus -2, x minus 2, x minus I, x minus -I. And so remember, we're reversing the solution finding process. We have solutions right now. We're trying to take it back to figure out what function would give us these solutions.
What does the dark blue say? Complex
Conjugate, the complex conjugate theorem that we just did up here. Yeah, that's what we're leaning on to find or to establish that negative I is also a solution. All right. So like I said, this first line right here, x minus -2, x minus 2, x minus I, x minus -I. Also, we have to put an A right here because we don't know if we're going to have to put a number out there or not in order to achieve that last condition, which was f of 3 is equal to -150. We don't want to put an x there because we already have x's involved. We don't want to confuse what we have going on. So you always put an A there, and then we'll come back to the A before we close out this problem. But right now, just put an A there just in case. So the -2 turns into x plus 2. And we have x minus -I, so that turns into x plus I. And so we have x plus 2, x minus 2, x minus I, x plus I. So now we need to go ahead and distribute, do a binomial distribution, multiply the stuff out, and see what happens. Remember, we're reversing this process. So if you have complex conjugates, it is best to go ahead and multiply those together. Okay, that stuff is going to cancel some things out, so it's always best to multiply those together. And we do have this over here with x plus 2, x minus 2, so we'll multiply those together. So do your binomial distribution. So all this is just your algebra working. X times x times -2 2 times x, 2 times -2. Then do the same thing. There's my orange at. Do the same thing for the next one. X times I, negative I, and I. That gives us this result, x squared minus 2x plus 2x minus 4, x squared plus ix, or could have did xi. Probably should do xi, but it doesn't matter, it's okay. Minus ix minus I squared. Any problems with the distribution? All right, so cancel out what's in common. 2x and negative 2x, but basically we combine it by like terms. I won't say cancel out what's in common, let's combine it like terms. And then in the middle, I squared, ix minus ix will cancel on the right. 2x and negative 2x cancels on the left. So that gives me x squared minus 4. And then don't forget, I squared should never be a part of your final answer. I squared is -1. X squared minus 4 times x squared plus 1 now. FOIL that out. X to the 4th plus x squared minus 4x squared minus 4. Combine your like terms. And we have 8 times x to the 4th minus 3x squared minus 4.
So that A stays there even though it was just imaginary?
We're not finished yet. I was
Oh.
just giving everybody a chance to.
Okay.
Yep. Didn't want to scroll up too fast.
Is TCC going to start reimbursing us for all this paper we got to use for one problem?
Man, this is called a good time, man. I don't understand what you're talking about.
That's your definition of a good time.
Look,
We're
man,
destroying trees, all right?
look,
We gotta get back to nature
well, you know, that's
and
what
our pockets.
we're building brain power. And so now you need to take what you learned here and figure out how to give back. I've done a calculus problem where, y'all know the whiteboards, the long whiteboards. When I write on the board, then I have to erase, come on back, erase, come on back. So, yeah, man, it's a good time, man. So, like Mr. Williams just suggested, we have this A sitting out here. So we have to figure out what A is equal to. And remember, we had one last initial condition that was given to us. That's when we plug in 3, we get out -150. So that's what we're going to do here to see what A is going to be, if anything, other than 1. Somebody said something. So plug in 3, and we plug in 3 into this. So that's why we have 3 to the 4th, -3 times 3 squared minus 4. And when I plug in 3, I'm supposed to get out -150. So that's why I said equal to -150. And we simplify, it's 81, 3 to the 4th is 81. 9 squared, not 9 squared, 3 squared is 9. 3 times 9 is 27. 81 minus 27 minus 4 gives me 50. Yep. Yep. You got it. Divide both sides by 50. I don't know if everybody's done with that purple or not. So A is equal to -3. Yep, now we know the function. We can take -3 and plug it in for A. Just giving everybody a chance to get there with me. That's what I did there in black. Distribute the -3. And now we are finished. Well, we can drop the -150 because all we want to do, we just use that to figure out what A was. And so now we plug in A and then distribute it into our function. And that's our answer.
So where did the 3 come from though?
You talking about this one?
No, up top, the F, instead of X, we put a 3.
Oh, that came from the beginning of the problem. Check out the last part of the beginning of the problem. When they gave you the directions, f of 3 is equal to -150.
Okay, so that's just the standard.
Well, it's what like in the next one is going to be f of 2. It's just they're going to give you what they want you to plug in
Okay.
in the problem.
And then it's just supposed to work out once you plug in. I don't understand what, like the underneath F3 minus -150, that equation, like where did that come from?
You
Like
said
if
which one?
scroll up a little bit. So where it says F of 3 equals A parentheses. Now the next one below. Like where did those that set of numbers next to it come from?
Well, we had this. That's f of x now.
And then you just put the 3 in where the X is?
Exactly.
Okay.
Yeah, whatever number they gave us right here, plug it in where x is.
Stupidest math ever.
Say again now?
It's so stupid.
I'm sorry. All right. Yeah, we can do it one more time. Whoever asked.
Hey, there's nothing like somebody telling you that your profession sucks, right?
17 years, man. I'm used to it. I don't know if y'all heard somebody in the back said that they wanted to do it one more time. So
I'm glad it brings you enjoyment, but
And I'm pretty sure that was the professor in the back saying he wanted to do it one more time.
Oh, man. So let's do it at least one more time, and then I will let you guys go. This time I didn't write it all in word form. I just wrote it bulleted form just to shorthand what we're trying to do. So instead of a 4th degree, this time we have a 3rd degree polynomial. They give us 2 solutions, and they say when you plug 2 in, you get out 91. So same type of instructions. Like I said, I just wrote it in bulleted form, trying to shorthand the directions here. Also, don't forget Monday, just giving you guys a heads up. You don't have to do anything different other than, like I said, I know sometimes, cuss words may slip out. Just hold them and put them in your pocket till Wednesday, if you could. But we got the dean that's going to be observing the class. Excuse me. Don't have to do anything different. Ask your questions. If I'm going too fast, ask me to slow up. Whatever the case, whatever you normally do that. I just like if you're being recorded, Zoom lets you know you're being recorded. I just try to let you know what's going on in the class. I'll give you a heads up. All right. So 3rd degree polynomial. So that means we should have 3 solutions. They give us 2. They give you -5 and they give you 4 plus 3i. So that means if they give you 4 plus 3i, then 4 minus 3i is your other solution. And remember, that's leaning on the complex conjugate theorem. That's what I have there in the green. Somebody said something. Yeah, yeah, might want to hold those witch jokes. Yeah, that would be beneficial. Unless you want to burn him at the torch, and that ain't got nothing to do with me. That's between y'all and him. So yeah, so going back to what we did last time, we want to, like I said, reverse engineer the process. So we're going to do x minus whatever our solution is. So be careful. Let me erase these red marks first. Notice how we set this up. We did x minus -5, x minus 4 plus 3i. So make sure you hold true to those parentheses. X minus 4 minus 3i as well. Well, you know, hey, whatever Zoom pictures y'all have, that has nothing, that has no bearing on my teaching ability. If you want to roll that way, then if you want to say death to all deans, I'm just saying I would let him know that I have nothing to do with. No, I'm just joking. Please don't. Please don't. All right.
Bro, you can't ask for an extension on homework and then threaten to like throw bad jokes when the dean's in class. You're fighting against yourself, man. Get
Right,
back.
right.
Hey, I never said I was about to throw bad jokes. I was saying the complete opposite. Like maybe I need to switch out my Zoom picture to something more agreeable to most people.
Kid friendly.
Well, I think communism is kid friendly. It's everyone friendly technically, but it's not really America friendly.
Well, don't get me on that because all I do is math, sir. All right. So negative and negative is positive, and then distribute that negative into the other ones. And we see that we'll have x plus 5. Then we have x minus 4 minus 3i, x minus 4 plus 3i. So make sure that minus sign hits each part of your solution and change the opposite signs. Oh, someone said something in the chat. Yep. Mhm.
Don't worry, that's just me being me.
Yep, not a problem. So now, just like I said before, if you have your complex conjugates as solutions, you need to go ahead and multiply those out. That things will cancel out for you. Now, you don't have to. If you want to go ahead and multiply x plus 5 times x minus 4 minus 3i, you can, but it wouldn't be the most efficient way of handling it. So I would say go ahead and multiply these first so that things can cancel out for you. So go ahead and distribute the x to each one, then you'll distribute a -4 to each one, then distribute -3i to each one. So the x plus 5 is going to stay the same. Let me move these slashes. And next you have x squared, because x times x is x squared, x times -4 is -4x, x times 3i is 3ix or 3xi, either way you write it. Then you distribute the -4, that'll give you -4x, positive 16, because -4 times -4. Then -4 times 3i is -12i. Then distribute -3i. That'll be -3xi. -3 times -4 will be a positive 12i. And then -3i times positive 3i is -9i squared. So make sure you pay attention to detail. Make sure you're paying attention to your signs. Pay attention to those i's, and you'll be okay. Any problems, any problems? So now combine your like terms. X squared doesn't combine with anything but -4x and -4x will give me -8x. We see positive 3xi, -3xi cancels out for us. Then we see -12i, positive 12i cancels out as well. Bring down your 16. And then we recognize that I squared turns to -1. So I have -9 times -1. Don't forget that we have that minus times -9, but -9 times -1, which turns into +9. So 16 plus 9 will give me 25. So we have x plus 5 times x squared minus 8x plus 25 now. And the second, we'll distribute that out to get the rest of our function. All right. So now we can distribute. We have x that we can distribute to each term, 5 that we'll distribute to each term. That'll give us x cubed minus 8x squared plus 25x plus 5x squared minus 40x plus 125. Combine your like terms. 8x, negative 8x squared plus 5x squared will give me negative 3x squared. Then 25x minus 40x will give me negative 15x. All right, and I didn't mention it, but don't forget we do have a sitting out front of all of, these steps. We got to figure out if a is going to be something other than one that we will have to distribute later. So any questions on how we got here? So now we go to that last initial condition that they gave us, which is f of 2 is equal to 91. So when I plug 2 into my function, I'm supposed to get out 91. So we're going to plug 2 in here for x, set it equal to 91, solve for a. So that'll be 2 cubed minus 3 times 2 squared minus 15 times 2 plus 125. And once again, it is equal to 91. Now, we aren't factoring anything right now. So is there something?
Right above a equals a parentheses x plus 5 in parentheses again, x to the second power minus 4x plus 3xi minus 4x. You know, the one at the top of the screen, just above that, where you have the two trinomials. How did you factor them out?
Well, we folded out. We just distribute. So because I just want to make sure we're clear. I want to make sure I'm saying the right thing. So factor is when you break it down, but when you distribute or folding it out, you just multiplying it out. So are you just talking about multiplying it out?
Yeah.
Yeah. So we did x times each one of those terms. So we did x times each one of those terms. Then we did -4 times each one of those terms over here in this other parenthesis. And then -3i times each one of those terms.
Okay, gotcha.
So yeah, that's why you have 9 different terms right here, because 3 times 9, we did that, each time. All right, everybody good? So got me distributing now. So 2 cubed, 3 times 2 squared minus 15 times 2 plus 125. 2 cubed is 8. 2 squared is 4. 15 times 2 is 30. 3 times 4 is 12. Add those together, we get 91. Anybody still on purple? Of course, let me know. Then divide by 91. A is only equal to 1. So that's good. Means we won't have much work to do left. Everybody done with the purple? All right. So plug in 1, all that is itself. So 1 times a cubed minus 3a squared minus 15x plus 125 is that. So that's our answer. So, some legitimate questions may not come up until you actually try the stuff out. So that's always the next step, to try this out. See if you can hold true to the process. If not, bring those questions to me and we can walk through it. Yeah. Questions on what we've done up to this point?
So if that was if A was anything but 1, it would have to stay out in front of that parentheses. But since it's not, or since it is 1, you can just omit it and leave x cubed minus 3x squared minus 15x plus 125 is the answer.
Well, it wouldn't stay out there. If it was anything other than 1, you would distribute it. Like we did the 3. Yep,
okay.
you would distribute it.
Okay.
Mhm.
Okay.
Appreciate it, sir. Appreciate it. Anything else? Anybody else before we close out today?
I got a question about last class homework.
Okay.
I'm really stuck on how to do long division, so I need help.
Okay. Let me see. Let me do this. Now, just in case it takes longer than the time that we have left, you couldn't make any more office hours? Because I want to make sure I don't rush through it.
I couldn't recently, but when is the next one?
Well, the next one is this today at between 3 and 5. But if you can't make any of them, shoot me an email and we can set aside a time, me and you, to make sure that you're
Okay.
completely straight. Yeah. So if that doesn't work, shoot me that email and we'll figure out when you're free and I'm free, and then I won't have to rush because I'm trying to, run to the next class or something like that.
Okay, that's fine.
Okay. Let's do that. I think that'll be best because sometimes long division can bring about a lot of questions. I want to make sure I don't rush through it and then you still have questions after we do a few. Yeah. So, all right. Anything else? Anybody else before we close? All right. You guys have a good one. Be safe. Have a great weekend. Oh, I also have office hours on Friday from 9 to 11 if anybody can make that. So, yeah, you guys have a good one. I'll see you in this class. Dean in the pocket. So, y'all take care. Take care.